everyone, and welcome to our new episode of Arabic NLP series. And today, actually, we are discussing a very challenging task in NLP, and especially in Arabic, which is about OCR, or optical character recognition. And actually, I want to give this short video uh, talking about our recent work about Qari-OCR, which is an Arabic text recognition model that we adapted using multimodal LLMs. Okay, so we can discuss this task uh, while understanding the technical behind these models, because actually they achieved really good results and people like it already, and they we have got many downloads like last month. So it is very important to understand how we can build such models, and plus how we can improve these models more and more until we have a really high quality, high accuracy of Arabic text recognition. And before, let's talk more about why reading Arabic text with a computer, which is we call it OCR, can be quite a challenge. Now, getting a text into a digital form is important, of course, for sharing information. We do searching, and of course, we analyze these documents. And OCR has uh, improved a lot for languages like English, but it is very complex writing systems like Arabic, and there are still many difficulties, right? As you know, Arabic language is cursive language, because meaning that the letters connect and change the shape depending on where they are in a word. And also we have these diacritics, which is the Tashkeel, we call it in Arabic, and these are very little symbols that are above or below the letters, and they are super important because they can completely change the meaning and of course how we pronounce the word. Okay, now existing OCR often struggles with these little marks. Okay, and there are a lot of Arabic fonts, as you know, and styles out there. So despite these challenges, now accurate Arabic OCR is really important. As you know, Arabic is spoken over 420 million people worldwide. Okay, and good Arabic OCR is very important for preserving the culture, heritage, and helping the researchers and making information accessible to everyone. Okay, actually the problem or the gap that we are discussing is current Arabic OCR tools often don't work as well as they do for English, especially when it comes to getting those diacritic right. Okay, so the gap so that's the gap that we want to address. Now, to understand where our work fits in, let's take a quick look how OCR technology has been uh, has been evolved over time. Okay, specifically for Arabic, and actually these traditional OCR systems like we had in the past, and this was very simple and had very limited support for Arabic complexities. And then came early deep learning methods like we call it CRNN, and these allowed for end-to-end reading, but still struggled with diacritic, different forms, different styles. Okay, and then transformers models improved how understand AI understand sequences of text, as we know, which is this is very helpful for the OCR models. And some researchers develop Arabic specific deep learning approaches, and then they using AI directly for Arabic's unique writing rules. And more recently, we have seen some foundation model such as Qalam were built specifically for the Arabic OCR and handwriting. Okay, and we have seen uh, the development of these multimodal LLM and vision language models such as Qwen. It's called Qwen 2 VL. Okay, VL for vision language, And then we can see like a summary of these different approaches and how they handle like Arabic features as shown in this table. So this is like included in the paper that I am going to put a link in the description for the paper and for the models, okay? So you can like have a deep look for this. And now let's talk about how we train Qari-OCR models using the dataset that we have generated, okay. And actually this is or maybe before talking about the model aspect, uh, uh, we generated the data, so we have like this scientific dataset generation pipeline. And this is actually one big challenge when we try to build like a really good Arabic OCR system, because getting enough high quality training data, especially data with lots of diacritic and different fonts and realistic page layouts, they are not easy tasks, okay. And it is not we don't have that much data with this high quality like in the public, okay. So we built a special system to create our own training data, and this process like had three main steps, okay. So we started with the text from two sources, mainly in Islamic text and news articles. And then of course they have like different fonts and diacritic and other styles, okay. And we use code to turn into text into images and like the scanned documents. Then we use HTML to control the layout, okay. We like chose 12 different Arabic fonts, different font sizes. And then we would like to see a real like book or document, okay. So that's why we then convert the HTML to PDF, okay. And then the PDF to into the PDF pages, I mean, into images, okay. And then we created different datasets, so different versions of the dataset with different sizes, just to try the models and to see how it fits when we do the fine tuning, okay. So we did like many experiments to find the best data size and uh, maybe achieving the high accuracy for the model, okay. Now what we did actually is we come up with different copies of these images, okay. And we did it like on purpose, because like applying noise, putting them like on with backgrounds, this will help the model to learn, or the model will learn to read text even in a poor quality images. And this is actually what we are going to see in the results, okay. So the end result was a large, diverse dataset perfect for training and testing Qari-OCR on all sorts of Arabic text challenges. Okay, so since we understood the part of generation the dataset, now let's move and see the Qari-OCR, how like we uh, we implement the fine tuning process. So on starting point, as I discussed, the base model, which is going to VL, and it was 2 billion model, okay, instruct model. And it is above a really powerful multimodal LLM, which handle both images and text, okay. So it has like this clever features like adjusting how it looks at images from of different sizes, I mean. And to make the training process efficient, especially since these models can be large, and for some limitation we used like techniques like 4-bit quantization, LoRa adapters, so which allowed us to fine tune the model without needing a massive amount of computing power, I mean. So the training was performed like a simple conversation, right? So we show the model the image of the text and prompt asking it to transcribe, and the answer is learned to give what was the correct text of that image. Okay, so this is very important. For the fine tuning, we did this iterative approach with different versions, and we come up with version 1, version 2, version 3, and we, of course, included in the paper the difference between these models, okay, and what make them special and what features they have, okay. So yeah, so this is uh, conclude our full pipeline from starting from the synthetic data generation and until fine-tuning this model using different approach of instruction fine-tuning using the uh, multimodal LLM. Okay, here is a complex. Uh, Maybe the images are not in the best quality, but you might see it like better in the paper. But here's like a visual example of how Qari-OCR handles the complex Arabic text or script. So as you can see the input images with the traditional Arabic text, and also I have highlighted some of the challenging features that making Arabic OCR difficult. Okay, so many of these like diacritic and other things that are in this script. Okay, and we actually make it hard because we include these things, these challenges when we generate the scientific data. So we take into considerations many of the challenges when it comes to the Hamza forms, the critic, the dos, the kashida, the madda, and also the classical language. Okay, so this is very important to include while generating the data with high quality in order to let the OCR model be able to detect that and recognize that and include it in the transcribed text. And actually, from the result, it does like a great job of recognizing most of the critical marks correctly, and which is like essential for reading and understanding the text. Actually reproduce the phrases, the structures like that comes in classical Arabic correctly, and actually this confirm how our models like achieve those high performance. Okay, and you can see the numbers of word error rate, character error rate in the paper. Okay. Uh, Now, as I have discussed before, beyond just like complex printed text, the model also shows like good performance when it comes to poor image quality, as you see, and even has some initial ability to handle handwritten Arabic. So this is example of the model's robustness. So the input image has like low resolution and cut off tightly around the text. Okay, and our Qari model and especially version 3 model, which was trained with this layout awareness, still provides like accurate prediction of the text. Okay, and this like shows it works well even with like purely images or text close to the edge or compressed layouts. Uh, so this is really useful. Uh, for digitizing historical documents. Maybe we have because we have a lot in Arabic that are not digitized. Okay, so this is one of the most important applications that can be built on Qari version 3. Also for reading handwritten, and actually this is what was not our purpose to do this. It is just only about scanned document as I showed before, but we found out that it can handle some of the handwritten scripts and give good results when recognizing them. So this is was very important conclusion for the model. And actually, let's discuss something before I conclude the video. Just there's are many there are there is like a very important aspects or uh, insights coming from our three models, especially when it comes to version 2 and version 3. And we should know how we can choose between them. And actually, when we discuss Qari version 2, which was trained on a large data set, maybe 50,000 images or samples, which focused heavily on getting the text itself right, okay, with a lot of diacritic and font, but less on page layout. So the model is actually our champion for overall plain text accuracy. So if you just need to extract the words perfectly, I think version 0.2 is likely your best model. And when it comes to Qari version 0.3, uh, this model was trained on smaller datasets, maybe like 10,000 samples, but one that specifically focused on complex page layout and structure like HTML tags. So this model is better at understanding how the text is organized on the page, and we included a lot of examples in the paper showing this. Okay, the difference between Qari 2 and Qari 3. Okay, uh, so uh, while version 2 gives like just a plain text, version 3 can sometimes be more accurate on complex page elements. So the trade-off is that because version 3 was trained on less overall text data, its general accuracy on a plain text might be slightly lower than version 2. And also, we looked at how computing power each model needed for the training, and this is maybe very important aspect because when we're discussing, for example, training version 3 on the smaller layout focused dataset was much more efficient, and actually it took less time, and of course it used less energy, okay, compared for the training of version 2 on larger datasets. Uh, so the conclusion is the best model depends on your specific goals. Choosing Qari version 2 for the highest accuracy in plain text reading, or choosing Qari version 3 if you need to understand and reconstruct the document structure. Okay, so this is very important, especially if the training efficiency is important for that task. Of course, when it comes to OCR, we still have some limitations. So that we are trying to do in the future work. So it might like you might see some performance with the Arabic digits or some struggling with some line spacing or character. Uh, it is not like a very big deal because we have tested and we have seen its capabilities, but it might fail in some complex text. Uh, okay, so yeah, I think that's it for. Of course, you can see other limitations when it comes to the performance of non-standard Arabic. Maybe it will be like suboptimal, but in general, our model like achieved really good results. And version 0.2 is from the state-of-the-art models for the Arabic OCR models. So what we are trying actually in the future is to enhance the robustness for more dense text, okay, and maybe text in graphs and charts. And we want to include more maybe non-standard, historical, and more layouts, more fonts, because we just found how we can control these multimodal LLMs with high quality in order to achieve the best results. So that's all for Qari OCR and Arabic OCR.